After drawing the single line diagram, we will have to write our components present in the single line diagram. Before that, I will add a generator over here, and we will check the circuit continuity using this option here. So now the generator is in the faded condition, which indicates that the circuit is not connected properly. So let me take this off. After connecting this and again checking for the circuit continuity, everything is fine. And let's start by writing our power grid over here. So double click on the power grid and the power grid editor appears over here. This has many tabs or pages. So every element will have an information page or the info page. In this page we will have the information such as the ID, device ID, the bus to which it is connected, and the equipment tag, name and description. And here the configuration is also present. This is for normal condition or normal loading category. We can also change this in the study case. And here this is the mode. It is put at default in the swing mode. So let me go to the rating page over here. So this is rated for a 110 kV voltage, and the short circuit values will be like 1000, X by R ratio 7, and this fills these impedance values with the 100 MVA base value, and everything else I will put on default over here and click on OK. So this updates the bus voltages over here. Bus 1 and bus 2 are now at 110 volt. Then go to the transmission line over here, double clicking on the transmission line. Again the transmission line editor comes over here, and this shows the information page, and from the information page I have the length selected over here. Let me change this to kilometers, and the length will be 5 kilometers with 5% tolerance. Then I will go to the parameter over here, and Etap has a large conductor library, so I will go to the conductor library. Let me select a conductor. I will select this conductor over here and click on OK. And then for the ground wire, I will go to the ground wire library over here and select the EPRI, and this I will select this cable, this conductor over here, click on OK. Then go to the configuration page. Then configuration type will be horizontal, and the height will be 30 feet, and the spacing will be 2 feet. So this updates the GMD value over here, and this will have one ground wire which will be at 4 feet high. After that is done, I will keep everything else in the default values and click on OK. And next for the transformer, double click on the transformer. This brings the transformer editor over here, and let's go to the rating page over here, and it is rated for 110 to 11 kV, and the MVA will be 12.5. So this automatically updates the full load current over here. And go to the impedance page and use the typical values over here. If you have the manufacturer data with you, you can enter it manually. Then everything else I will keep on the default values. And over here we have this cable over here. Let me select this cable, and the cable editor appears over here. So the length of this cable will be 10 feet, and let me select the cable from the library. So I will select this cable, which is the frequency copper type, which is rated for 15 kilovolt, and the underground ampacities and the ampacities are also shown. So let me select this cable size and click on OK. Everything else will be in the default values, and click on OK. And I will do the same here. And for the load, I will double click on the load over here and go to the nameplate, and this will be 2 megawatts operating at 97% of power factor. Okay, I want 2 megawatts over here. Okay, now it's fine, and click on OK. And here the load will be operating at 94% with 3 megawatts. Okay, and the load connected to the composite network will be 1 megawatt, and that will be operating at 89.4% of the power factor, and click on OK. And for the generator, we will double click on the generator over here, go to the ratings page and use a 3 megawatt generator, and go to the impedance model over here, or else you won't get the correct capability curve. So go to the impedance model over here. If you have the manufacturer data of all these impedances and the dynamic model, use that, or else use the typical data option over here. And coming back to the capability curve, I will use the capability curve to determine the reactive power limits, and I will be generating about 1 megawatt using this generator. Everything else I will put on default. Click on OK. And this is how you rate your components in Etap. So every element will have different editor windows, and it's up to you to provide these values accordingly. Sometimes if you don't provide the model data of generators or motors, then you can conduct certain studies such as transient stability studies or motor starting analysis, etc. So you will have to provide your values to your components before running any simulation.